Let's get started on Prophecy for Databricks. After logging into Prophecy, create a project called Reporting. All the pipelines that you're going to build are turned into high-quality code. Here, you can choose the programming language of that code, either Python or Scala. Prophecy will store all of that code in repositories on Git. Git enables you to version your changes, collaborate with your team, and track exactly what code is deployed to production. You can connect to one of your existing Git repositories. If you don't have one, Prophecy can create one for you. As part of our reporting project, let's create our pricing report pipeline. Connect to a Spark cluster. With one click, we can see our Spark cluster running in Databricks. Coming back to the Prophecy UI, we're going to build a pipeline to report the amount of business that was billed, shipped, and returned. With Prophecy, I can read and write to any data source. We're going to read from Snowflake. I store my credentials as Databricks secrets. Read from the order shipments table. We can see the schema right away. Load a data preview. The data looks as expected. Each record is an item to be shipped. We'll use the columns relating to price and shipping status. Let's start to design our pipeline by choosing some transformations. A reformat gem to clean up the data, an aggregate gem to sum the amounts, an order by gem to order by shipment status, and then a target gem to write the report to a catalog table. Configure each transformation. Select the columns of interest for our pricing report. Create some expressions to clean up some bad data. If the tax is 0, specify a default value. Let's also create a column to capture a business rule, a case when statement marking an item as clearance. Configure the aggregate expressions. Start with basic SQL functions, and Prophecy will help you build expressions. Later, Prophecy will convert these Spark SQL expressions into Python or Scala. Compute a sum, count the orders, and whether an item was marked clearance. Group by whether the item was returned or delivered. Run the pipeline up to the sum amounts gem. Organize the canvas. And let's see what we've got so far. We can see the interim sample output from each gem. Data types are correct. We can see the summed amounts and orders, the returned or delivery statuses, and how many of these orders were marked clearance. We can see some basic statistics for each column. Configure the order by gem. We want to know if the item was returned and or delivered. Configure the target dataset. We'll choose to write to a Delta catalog table. Specify the details. and some properties. Here, we'll overwrite the table schema, but there's lots of options. Run the pipeline one final time to write the report to a catalog table. We designed our pipeline. Let's see what the code looks like behind the scenes. Here is the graph representation. Each function represents a gem: the shipments dataset, the cleanup function, the sum amounts function. See the cleanup function code. This is what you write as a highly skilled data engineer. Great. In the next training, we'll see how to commit our code to Git, version our changes, and schedule and test our pipeline. See you next time.